19, so advertising only 4 extra prefixes instead of 10. We see plenty of people deaggregating massively. So as an example, a /19 is chunked up into 32/24s. Every prefix with just the same identical AS path. So probably there is no reason to do that. It's probably just because they don't know better. Okay, so we actually managed to balance our traffic flowing into our network. The drawback is we polluted the global BGP table a bit with a number of prefixes, but so what, who cares? No one really would blame us, especially our suppliers won't, because they get more traffic, or especially AS2 won't. We lean back, mission completed. But now it happens that the peering coordinator of AS3 is a clever guy, and he noticed that a lot of more traffic is flowing via his expensive transit link AS3 to AS2. And he figures that, okay, AS4 started to propagate more specifics, and this makes me more cost. So he's smart, he implements filters on his border routers and filters away all the /17, and you start from scratch again. So content wins 1-0 versus eyeballs. No, we want revenge. Prepending doesn't work. No. Special selective advertisement. No. Only with redundancy degradation. More specifics. Pollution of the BGP table. Well, not really a smart way to do it. We get filtered. Any other ideas? Okay, there is a possibility of most upstream providers, which is called BGP community support. And we need to instruct the upstream provider how he should treat our routes, our prefixes. So most transit providers do support communities, and if your transit doesn't support it, you probably should consider someone else. I shared a link here at the domain 1sc.net/communities. There is a not really it's an incomprehensive and also a bit outdated list of transit providers which do support BGP communities for traffic engineering. So I suggest you have a look there first, and then in case talk to your vendor what they support. They usually have a document of a few pages which can help you in this. So back to our example. Most networks or most community supporters do not announce to peer X or prepend 1, 2, 3 times to peer Y. There is also usually a setting which allows please black hole this and this IP address in case you get the DDoS attack, and other settings. But I have about 5 minutes left, so should be brief in this. If we start to instruct AS1, our one transit, not to announce 10/13 towards AS3 via this link, then the traffic will flow for each of our 2 prefixes we have via AS1 and AS2. And if AS1 breaks, they still have a backup path available. BGP communities is not the latest and ultimate way to manage traffic engineering. It's a combination of all of them. So sometimes you have to use selective prepending. You prepend one prefix. You don't do it with another. Sometimes you have to advertise more specific, but don't make 32/24 over /19. Just do make 2 of one prefix. Sometimes you have to use PHP community support of your vendor, or a combination of all of it. If you use any of these methods, know exactly what you expect what you're going to do. There are people out there which just randomly prepend and have no idea what's going on and what they expect. So it's a bit tricky. You can break seriously your network, and you have to know what's going to happen if you turn a knob. Last but not least, and I can just quickly mention this, there is also caching servers available from large content providers like Akamai, Google. I think Mike will talk about later this afternoon about this. So if you can physically manage to shift servers from AS3 to AS4, you're also done. And your capacity is available for other purpose. So this is my last slide, and I'm happy to take questions. No questions? So you can always catch me later if you have specific questions to talk. Yeah? I'm here for the rest of the day. Thank you.
Okay, thank you, Freddie. Next presentation is from Will Hargrave.
Hi everyone, and good morning. My name's Will Hargrave. I'm Technical Director of LONAP, which is an internet exchange in London. I'm very aware I'm keeping you from lunch practically here, so I'll try and be swift. So, what am I going to talk about? Well, this presentation is aimed for 2 sets of people, peering networks, understand why and what root servers are and why you might want to connect to them, and for internet exchanges, understand how you should deploy root servers and how they might increase value for your members. I'm going to give you a summary of root server technologies without getting too technical, some do's and don'ts, and most of this is basically my personal opinion, so take that with a pinch of salt. Let's start with some terminology. We have this problem. I'm British. I usually say router. Americans and Australians say router. We're in a Commonwealth country here in Tanzania, so I'm going to keep on using British English if you don't mind. So, root server, which you've already heard about if you were here earlier on in the week, a service for internet routing diagnosis that collects and it's a useful source of information. That's not what I'm talking about here. I'm not talking about root name servers either, which are part of the DNS infrastructure. What I'm talking about is an IXP deployed service for multilateral peering. And yeah, I guess we're using the same phrase for lots of different things. Sorry about that. So, what is the problem we're trying to solve? Well, a small IXP with say, 10 participants needs 90 BGP sessions if they're all going to peer with each other. If you get into a larger IXP, I mean, at LONAP we have, I think, 106 connected ASNs now. That's a lot of BGP sessions you need to achieve this full mesh. And certainly in Africa, as you see increased competition and IXPs grow, you're going to hit this. You're going to be in the same position as Europe with IXPs with 300-400 participants. So you need to plan for that to make it easier for your members. There are some other reasons why you want this service. Language barriers. So initially, internet exchanges start in just your home country, and as Michuki said, you're seeing a lot more people from other countries building into neighboring countries, and maybe get some language barriers. For instance, there's a lot of Russian networks building into Europe, and they may not speak English as well. So if you don't have to coordinate with another peer to set up sessions, that can be an advantage. Another advantage is new members begin passing traffic straight away. So someone connects to your internet exchange, they only have to set up a couple of sessions and the traffic comes. And maybe you can get some peering you wouldn't otherwise get. This is a quote from Google's page on PeeringDB. I must say it applies only in Africa, America and Western Europe, but basically what Google is saying is we'd rather not spend lots of time administering sessions for small amounts of traffic. we want to use the root server service to make it easier. So here's a small IXP with 6 members, right? So these coloured lines are the BGP sessions. So you can see you have some sessions there. And the next stage is we introduce the root server service. Now, as you can see, there are 2 boxes which set up sessions with each peer. And it basically means these purple dotted lines, which are the BGP sessions, are not necessarily needed. You can keep them, but in reality, you have a smaller number of sessions required. So, key points. The IP traffic doesn't transit the root server. These are boxes that are just attached to your IXP LAN, and their purpose is to reflect the BGP routes which they receive from members to other members, with changing as little as possible. This is multilateral peering, right? The whole point is this looks like a direct BGP session, but you don't have to have the overhead of communicating with the other peer and setting it up. So, what do you use for these? Why can't I just use a regular router? I mean, I have some hardware hanging around. Well, this is a bad idea at present, because you actually need some special magic for root servers in the BGP implementation for it to be useful. And that's why very few people are actually using Cisco or Juniper boxes for this purpose. So there are a few features that are missing, like at the moment if you use an ordinary router, it will always insert its AS in the AS path. More about that later. You want attributes to be left as unchanged as possible, so it looks like an ordinary session. And there's a thing called per period, which I'll go on to as well. As you all probably know, when you have a peering session with someone or you buy transit, the AS number that the route is transiting appears in the AS path. Now, as Freddie said, AS path is important, and you don't want this to occur with your root server, because the traffic is not actually transiting your root server AS. It's conceptually wrong in my mind. So longer AS paths mean that actually the traffic might take a route not via the IX, and the user doesn't see the value from it at all. You want it to be transparent, and that's the key thing here. And the other thing is, though, is that your peers need to have some bits of config here because normally routers expect to see their peers' AS in received routes. You can turn that off. That's okay. Another feature that's not in typical routers is what we call this per peer rib, and that's where you actually build a rib for each peer. It's personalized for each peer you're sending the data to. This is pretty mandatory, where you have more advanced policies driven by communities and so forth. So what software can I use for root servers? Well, there are about 3 implementations that are widely used, all open source software, and there's also a Cisco root server service. So, well, starting in alphabetical order, there's Bird, which is open source software developed in Prague by some Czech guys. The first deployment was by us at LONAP 2 years ago, and since then now it's pretty widely deployed at links. You know, all those names you've probably heard of. It's been tested. I've got some references and presentations on this, and it's proved very effective for a lot of IXPs. And it's open source, right? It's free. This is great. We like that. There's a Cisco root server service which is starting to become into production now. At the moment, I believe it's just in engineering builds. But what this will basically mean is you can use an everyday Cisco router as a root server. And this I think will come along in the kind of mainstream ARS builds in ARS 15T next year. At the moment, you can get these ARSs. If you look at this website here, there's a lot more information, some presentations from Robert Razak on this. So what other BGP daemons are we using out there? OpenBGPD. We also run this at LONAP. This runs on OpenBSD. Again, open source. It's fast, multi-threaded, and it has ongoing development. It's mainly used at AMSICs. They have a big OpenBGPD implementation. And then the last one is Quagga, which is venerable, I would say. It's quite an old bit of software, evolved from Zebra. It has had some scalability issues.